We're going to talk about dividing fractions in just a moment, but before we do, we want to talk about the reciprocal of a number, because the notion of reciprocal is used in the process of division. Now, a reciprocal is a number which is related to a fraction. Usually we're talking about a fraction when we talk about the reciprocal of a fraction. It's just the fraction flipped over. You see, the reciprocal of 3/4 is 4/3. You see, you just take the numerator and make it into the denominator, and the denominator becomes the numerator. So we're just kind of flipping it over like this. All right, the reciprocal of 1/5 is, well, flip this rascal over and we have 5/1. Now we can write it as 5/1 for emphasis, but we know that this would become just 5. Now the reciprocal of a whole number like 3 is, well, to see what it is, we think of 3 as being 3/1. So now flip this over, you see, and it becomes 1/3. So we can have reciprocals of whole numbers as well as fractions. Now, let's talk a little bit about division. We know that 10 divided by 2 is 5. We know that because we can go through the long division process. We can say 2 into 10 goes 5 because 5 times 2 is 10. Now, if we try to use the same strategy with fractions, though, look at what happens. 2/3 divided by 3/4. Well, that would be 3/4 into 2/3. You see, we don't use this process in order to deal with fractions. We use this idea. Now, 10 divided by 2 we know is 5, but it's also true that 10 times 1/2 is also 5. And here's why. It's 10/1 times 1/2, and the 2 and the 10 cancel. 2 into 2, 1, 2 into 10, 5. 5 times 1, 5. 1 times 1, 1. 5/1 is 5. So we get 5 for the result of both of these, and it's no accident. It turns out that dividing by a number and multiplying by its reciprocal, you see 1/2 is the reciprocal of 2. Multiplication by the reciprocal is the same as dividing. And that's the idea that we use with fractions. So we think of when we face a problem like this, 2/3 divided by 3/4, we change it into a problem like this. We say dividing by 3/4 is the same thing as multiplying by the reciprocal. So we take the 2/3 and we multiply by the reciprocal of 3/4, which is 4/3. And now we use all of our strategy for multiplication of fractions, and 2 times 4, 8, 3 times 3, 9. 8/9 then. So 8/9 is 2/3 divided by 3/4. All right, so in all of these problems, we're going to, rather than divide directly, we kind of go through multiplication when we're dealing with fractions. Let's take a few examples now. 3/7 divided by 4/5. Again, we change this into a multiplication problem, and we do that by bringing down the first fraction, and then we multiply by the reciprocal. So flip that over, we have 5/4, and away we go. We have 3 times 5, 15. 7 times 4, 28. So 15/28 is the answer. In this one, 5/9 divided by 15/28. Again, we don't divide directly. We change it into a multiplication problem. It's 5/9 times reciprocal, 28/15. Now let me point out to you one of the commonly made mistakes in this process. It is to look for a cancellation opportunity in this division step. Now we know that we can cancel when we have the multiplication of fractions, but we haven't talked about cancellations in this division step. And in fact, we can't cancel in this step. We don't even try to cancel in this step. We want to be very patient and go to the multiplication step and then look for the cancellation possibilities. Now I'm looking for cancellations here. Now up here you see we would be tempted to cancel the 9 with the 15. 3 goes into both of them. We can't do that, but we can look for cancellations here, and we see a couple of them, or we see one. 5 and a 5, 1. 5 and a 15 goes 3. And now we multiply straight across. 1 times 28, 28. 9 times 3, 27. Improper fraction. 27 goes into 28 one time with 1 left over. So it's 1 and 1/27 for the answer. Here's 3/4 divided by 5, so we're dividing by a whole number. Now, when we multiply by the reciprocal, we have to think of 5 as 5 over 1. Now, to emphasize the idea, you might just put the little denominator of 1 in here, just to make sure we understand that we're going to change this into 3/4 times reciprocal is 1/5. And now we multiply straight across. I don't see cancellations, you see, so 3 times 1, 3, and then 4 times 5, 20. So 3 over 20 is our answer. When mixed numbers are involved, we have to take our time with the problem. We have to change the mixed numbers into improper fractions. We also have the task of flipping over the second fraction, that is multiplying by the reciprocal. And we have to take care not to do too much at one time. Now, in this problem, 4 2/3, I want to change to the improper fraction form. So 3 times 4, 12, and 2, 14. So this is 14 over 3. And this is divided by 8 over 15. Now, the temptation would be to go ahead and change this to a time sign and flip this over. And in this particular problem, where this is already a fraction, it would probably be okay. That's kind of a safe thing to do. But as a precaution, I suggest that you use one step to change any mixed numbers into improper fractions, and then a separate step for changing into the multiplication by the reciprocal idea. So we have here 14/3 times 15 over 8. And now we look for cancellations. I see a couple of them. 3 into 3 goes 1. 3 into 15 goes 5. Let's see, for 14 and 8, 2 divides both of those. 2 into 8 goes 4. 2 into 14, 7. Multiplying straight across. 7 times 5, 35. 1 times 4, 4. 35 over 4, an improper fraction. I can't see the mixed number very easily, so I'm going to come out to the side and show the long division here. So it's 35 divided by 4, or 4 into 35, like this. 4 goes into 35 8 times. 8 times 4, 32. 5 minus 2, 3. 3 is the remainder, so we put the remainder over the divisor. So 8 and 3/4 is our answer. Let's just move that right over here. This is 8 and 3/4. Here's another one. Now notice this one, we have a mixed number here and a mixed number here. So in our first step, we're going to just change mixed numbers to improper fractions. We're not going to try to both change mixed numbers to improper fractions and flip over that second fraction. See, we're not going to do that. All right, so here we go. 15 times 1 is 15 plus 13. Wow. 15 times 1 is 15 plus 13. Now, it might be necessary to come out to the side, you see, and think about that. If it's not real clear what the result of that is, just go out to the side and think, well, let's see, I'm just taking 15 and I'm adding 13. What is that? You see, don't be afraid to do this. 5 and 3, 8. 1 and 1, 2. So that's 28. That is, 15 times 1 was 15. 15 and 13, 28. So this is 28 over 15. Okay? Don't be afraid to do that, because if you're afraid to do that and you make a mistake in this process, then you're letting some kind of pride cause problems with your mathematics. And you don't want to do that. You want to be very safe with everything that you do. All right, so we have 28 over 15 divided by 5 times 4, 20, and 1, 21 over 5. And now we change to a multiplication problem. It's 28 over 15 times, flip over, 5 over 21. And now I'm looking for cancellations. I see a nice one here. 5 into 5, 1. 5 into 15 goes 3. Look at 28 and 21. Is there a number that divides both of those evenly? Sure. And the number is 7. 7 into 21 goes 3 times. 7 into 28 goes 4 times. Now going straight across, 4 times 1, 4, and 3 times 3, 9. So the answer is 4/9. Here's a word problem that is solved by dividing mixed numbers. I think it's important for us to realize how we come to know that the problem is solved by dividing mixed numbers, and how we interpret the problem, how we think through it to get at the idea of what is the divisor and what is the dividend and so forth. Let's read through the problem. It says KU Energy stock is offered for 31 5/8 per share. Now that means 31 5/8 dollars per share, but when talking about shares of stock, generally dollar signs are not used. How many shares can you buy for $1,265? Now you may interpret this problem immediately and understand what has to be divided here, but a lot of times if a problem is confusing, you just restate it in another way. Just say the same problem in another way. And here's another way to say this problem. $1,265 can buy how many shares at 31 5/8 dollars per share? That's another way. Here's a third way. We have $1,265. Something, we don't really care that it's stock, it could be almost anything. Something costs 31 5/8 dollars each. How many of those things can be purchased? In other words, how many 31 5/8 units are in 1,265? You see, how many 31 5/8 are in 1,265? That leads us to think about, well, that means how many times does 31 5/8 go into 1,265? And the notion of 31 5/8 going into 1,265 means what is 1,265 divided by 31 5/8? Well, we're just about there, but let's reinterpret another time. Let's go through and organize the information again. The amount of money we have is $1,265. And the cost of one item we want is $31 and 31 5/8 dollars. And how many items can we buy? And these are the most important facts and the question that is being asked in the problem. And this is what I want to emphasize here, is the interpretation of the problem is just as important as going through the process of the division here to get at an answer. We have to be able to interpret the problem in order to be able to solve it. Well, from all of that, we understand that 1,265 is being divided by 31 5/8. Our first task here is to change 31 5/8 into an improper fraction. And recall, what we do is we multiply 8 times 31 and then take that product and add 5. And when we do that, we find that the fraction is 253 over 8. Now the 8 times 31 plus 5 will give us the numerator of the improper fraction. And it's important to understand that the denominator is the denominator in the 5/8. That is, it is the 8. So 253 over 8. Now 1,265 divided by 253 over 8, we're going to change the sign to times and flip over the fraction. Flip over the, well, this isn't exactly what I mean by flip over the fraction, but you know what I'm talking about. It's actually 8 over 253. And when we divide like this, we think of 1,265 as being 1,265 over 1. Now our prescription for multiplying fractions is to multiply straight across. And in the numerators, 1,265 times 8 would be 10,120. In the denominators, 1 times 253 is 253. Now notice I didn't even pause here to think about a cancellation opportunity. We're going to come back and look for that opportunity in just a moment. But if we just look at the problem, we don't see a ready-made cancellation and just multiply straight across, that's perfectly all right. Here we have an improper fraction on the right. We need to change it to a mixed number or maybe to a whole number. And to do that, we'll take 10,120 and divide by 253. So it's 253 into 10,120. 253 into 1,012. You see the first 4 digits will go 4 times. 4 times 253 is 1,012. Oh, happy day. It kind of goes evenly, doesn't it? That means that when we subtract here, we get 0. If we bring down the next digit, we get 0. The division is trivial. 253 into 0 goes 0 times. So the notion here is that 10,120 divided by 253 is 40. Our answer is 40. But Before we write the answer, I'd like to show you another way to proceed with our thinking on the problem. You see, we might investigate the possibility that 253 will cancel with 1265. And to make that investigation, we do this. We think of 253 dividing into 1265, and we just want to see if it will go evenly. And it turns out that it does. It goes 5 times. Because 5 times 253 is 1265. And that means that there's no remainder in the problem, and so we have a cancellation opportunity, and we can take advantage of it like this. We say 253 into 253 goes 1 time. 253 into 1265 goes 5 times. And now going straight across, 5 times 8 is 40, and in the denominators, 1 times 1 is 1. 40 over 1 is 40. Now, after all of this time, you may have forgotten what the problem was even asking us to find, but let's go back to it and decide how we're going to think about our answer. Here's the original problem, and the second sentence says, how many shares can you buy for $1,265? Well, we determined that the number of shares is 40, and we'll write our answer as a complete sentence. We can buy 40 shares of KU Energy stock. Here's another problem that is solved by dividing mixed numbers. It says a car used 15 1/2 gallons of gasoline on a 310-mile trip. How many miles can this car travel on 1 gallon of gasoline? So the interpretation in the last sentence is that we want the miles on 1 gallon. You see, the miles traveled on 1 gallon, and that means miles per gallon. And remember that the per idea can be thought of as a slash like this, and the slash can be thought of as the fraction bar in a fraction, and a fraction leads to a division problem. So we have miles over gallons, or miles divided by gallons, and that's 310 miles divided by 15 1/2 gallons. So the fraction bar means divide, and away we go. And just like before, we'll change 15 1/2 into an improper fraction. 2 times 15 is 30. 30 plus 1 is 31. So that improper fraction is 31 over 2. And now we change the sign to times, flip over the fraction. So we're multiplying 310 times 2 over 31. The 310 is thought of as 310 over 1. And away we go with the multiplication. Now we can multiply straight across and then resolve our answer if we want to, or we can cancel, and I think it's pretty easy to see the cancellation here. 31 goes into 31 1 time, and 31 into 310 goes 10 times. Then multiplying straight across, 10 times 2 is 20 for the numerator of the answer. 1 times 1 is 1. 20 over 1 is 20, so our answer is 20. And we'll write our answer as a complete sentence. The car travels 20 miles on 1 gallon of gasoline.